Hi, my name's Andy Mills. I'd like to run you through a quick introduction to the FuzeDrive technology here from Enmotus. FuzeDrive is a software technology, software that runs essentially inside of Windows or Linux servers or PCs and virtualizes storage devices. In effect, we fuse different drives into a single large disk drive. Once we fuse them together, the software is able to automatically move data back and forth between the devices in real time. And by real time, we mean within seconds, not something that happens within hours or days as you typically find in old traditional Turing architectures. And lastly, FuzeDrive gives you a number of tools for the first time in the industry that help you visualize with volume maps and activity overlays where SSDs live, where hard drives live, etc. And secondly, tools that allow you to manipulate data in such a way that is very fast and convenient for the end user. So essentially, FuzeDrive is a technology that will take several physical devices. As you can see here, we've illustrated PCIe SSDs, M2 SATA, M2 PCIe, actually even the WD Black 2, which is a hybrid or a dual drive configuration with SSD and hard drives integrated, hard drives, pure SSDs, SAS SATA, and of course RAID block level devices. Essentially any block level device can be incorporated into FuzeDrive. And what we do is we classify those devices into one of two categories: fast or slow. As the name suggests, you put all your SSDs that go fast and typically expensive in the fast bucket, and the hard drives typically, or slower, cheaper SSDs, and the RAID adapters with hard drives on them tend to go in the slow tier. The purposes of doing that is our software layers then will enable us to virtualize those fast, slow devices as one large pool of storage to the operating system. And two other important features that we have beyond just the pooling or the hypervisor-like architecture is that we will gather data intelligence, and we will automatically migrate the data based on that intelligence. That's all with the net result of here producing a highly intelligent virtual disk that appears to the operating system. And all of this happens, as we show here, in a Windows or a Linux block driver level. What this means is this is truly well below the file system layers. It's below the logical volume layers, below the hypervisor, even in some cases the operating system hypervisor. It truly is something that operates entirely in the block layers. Now, the benefits of that is compatibility. This will drop in to just about any application running in a standard Windows or Linux environment, including cloud, cluster, database, and exchange servers, all those kind of things easily incorporate this kind of technology. And your intelligent virtual disk is going to appear to the operating system as a dumb disk drive. Even though it's highly intelligent, we've designed it in such a way it still plugs in as a regular everyday disk drive. Hence the benefit of being a block level implementation or architecture. So that's the FuzeDrive technology. If we look at some of the features in those mid layers that we just outlined, the storage hypervisor virtualizes storage devices, as we said earlier. But more importantly, it removes device vendor dependence. That means I can put anything below that layer pretty much that we support, and it's still always going to look the same to the operating system above it or the applications. That allows you to change and swap out different vendors of SSDs without having to worry about any impacts on your operating system or applications. And certainly because it's OS agnostic, of course, you're not and vendor agnostic, you're not having to change your whole software stack just because you changed the vendor. So that's a very important aspect here. And very importantly, it operates at the block layer and even sub-hypervisor layer. That means this will appear to a hypervisor, an OS hypervisor, as a dumb block device, even though, again, it's highly intelligent and moving data. The second thing that goes on in the Enmotus layers is data intelligence gathering. For every I/O that goes on in the system, we have a very low overhead intelligence gathering engine, and that will keep real-time statistics of all the I/Os that have happened across the entire volume, not just the SSD portion, not just the hard drive portions, but the combination and the full, the full volume here. That's very important because it allows us to monitor trends over time and really make better decisions on where data, goes. And obviously, that's the whole point of this engine, is to make sure that the most important data to you, the user, ends up on the right device that you paid presumably the most money for. And finally, the real meat of the Enmotus engine is the micro-tiering technology. This is fully automated data movement. You can set and forget this technology and let it just carry on and do its thing, and it will load balance within seconds as new data comes in. Again, operates at block layers, not the file layer. That keeps it entirely OS and file system independent. And we have tested this on many different kinds of file systems, and it really is just like another disk drive as the file system is concerned, but of course, as we know, a lot more intelligent. And we were able to do a couple of neat things in this micro-tiering architecture, and this is all down to a very novel page exchange algorithm that allows us to present almost 100% of the SSD and the hard drive capacity combined, which means that you not only get high performance out of this system, you also get the most efficient use of all your capacity in the system. So your dollar per gigabyte and your performance per dollar per gigabyte really do improve significantly with this kind of solution. So why FuzeDrive? So as we've just said, the users get the benefit of an all SSD-like performance in their system, but at a fraction of the cost. Number two, the software hybridization technology here allows you to choose whichever SSD and HDDs you want to combine, from any vendor. You don't get stuck with a specific vendor solution. So you're able to be somewhat independent of that now, rather than being tied to whatever a vendor will offer you as they come through the door from the SSD world. Capacity efficient. The algorithm we've developed here allows you to do a couple of things. One is, as we've said, the capacity is additive, but a secondary benefit here is that there's no limit on the size or ratio of the SSD to hard drive or fast to slow ratios here, or capacity ratios. What that means is I can take a 1 terabyte SSD and combine it with a 1 terabyte hard drive, and I have a 2 terabyte 50/50 kind of device. Now, why is that important? In applications such as streaming video or rich media, a lot of those files get pretty big, and you want them to be sticky and stay up there potentially for a reasonable amount of time, especially in a web media server delivery application, and you may have an exceptionally large number of those files. So what this no limit does for you, it allows you to create very flexible ratios, not just capping out at 10, 15, 20% of the back-end storage. You can just keep on going, adding fast tier stuff, and over time, of course, you can dominate that with the fast tier stuff as you're migrating customers over time. So a lot of benefits to no longer having that restriction to your capacity ratios here. And then finally, one of the things that obviously is that should not go unsaid is that a single solution that supports both Windows and Linux can dramatically keep your support costs down. You do no longer have to train two sets of people if you're a vendor. If you're an IT manager, you no longer have to learn two different ways of doing things. It's going to be the same whichever operating system that you're using. Very important. So let me touch on two aspects quickly on the FuzeDrive architecture that I believe are very important and make this more than just an average kind of data migration engine here, or beyond average. File pinning is one of them. FuzeDrive file pinning here is one of my favorite additions to the software. We've gone to the extent of building this into the Windows Explorer. In the case of Windows, Linux is still command line, but you get essentially the same set of functions here, or functionality. quite simply, you open up your Windows Explorer, browse to where your files are located, of course, on your volume here. And what you're going to see first and foremost is when you right-click a file, a new little addition happens down at the bottom here, which is to your normal standard list, and that's called FuzeDrive. Now, a couple of things that's kind of interesting. So that's just a simple right-click here. The first thing is you're going to see that the FuzeDrive has detected that this file is only 8% tiered in this particular application. So obviously, as that suggests, only 8% of the media has been located underneath that file. That could have happened for a reason. You might have only played partially this file. In this case, it's I believe a video clip, so you may have only played the first part of that video clip and then stopped. So it's obviously recognized that first part needed being pushed up, and you may have only played the front part of that. But obviously in some cases where you know there's going to be maybe a large demand for this, and this can be an image not only for video in this case, but it can be an image for VDI or bootable applications as a server, where you know you want to have a certain image, by 8 o'clock in the morning up there on the fast tier, as you know you're going to get a lot of logins, then this is a way to be able to push a particular version up, ahead of time. So right click the file, you get this other menu, that sub menu that then appears after the FuzeDrive section appears, that allows you to promote or demote the file. So notice also that you're able to pin the file either permanently to the fast or slow tier, or promote it to the fast or demote to the slow tier. You can do this permanently with the forever setting, or other settings that we've provided here as an option, between 5 minutes up to a week. Again, useful for knowing when you've got burst activity where you want to set, forget, and just leave it to get on, with the tiering aspect all on its own, so you don't have to come back to it to reset it later. So a lot of flexible options there, and by far one of the most popular aspects of the Enmotus tiering engine as we get out there with this solution. And finally, for the advanced expert users, you certainly do have command line versions in both cases for those who wish to script and create other custom variants of when to have data on the fast or slow tiers. Very, very flexible, very easy to use command line interface for those interested in that kind of aspect. The second thing that really is nice about the FuzeDrive engine is its visibility into where the physical media is actually placed in this new intelligent volume we have. And one of the first things we learned as we went out there talking to people about the Enmotus solution was, I think as people have used caching and other solutions, you certainly get all the performance meters and the capacity hit, the cache hit rates. These are things that don't apply in tiering. In our case, we're more concerned about where data actually lives or where it's placed. Because we're a data migration engine and a virtualization engine, it's more important to know where the SSD is in relation to current and past activity. So we show here, for example, our eLive monitor, and what we're showing here is a real-time map. Obviously, this is a screen capture, but for the system, this was captured off. What we're showing is a real-life map of our intelligent volume, a terabyte in this case. And the blue regions represent the slow tier. The red regions here represent the fast tier. And we're looking at it in like a volume map view here. And then overlaid on top of this is the activity within each one of these regions here. Now we do keep statistics of much finer granularity than we show here, but for the purpose of displaying, it was easier just to collapse it down into 64 groups here and just show you what happens in each one of these regions. So a couple of things jump out. First of all, this is a very active region. This is where most of the SSD has been relocated to. It might not be the highest activity right now, but aggregate over time, it's obviously made the decision to move the majority of the pages in that region have been moved up. Actually, or more correctly, the media has been moved under the files that are mapped to that LBA logical block address location here, or region on the volume. So this all happened automatically. In this case, there was no file pinning involved. But you can see what's happened is for this terabyte disk here, and this particular disk is the WD Black 2, for example, has a terabyte of just over a terabyte of storage, of which 120 gig of that is the SSD portion. Now, what we're seeing here in these little bars is the activity that's going on right at that moment. There's another view which we'll show you in a later tutorial you can switch to that basically shows you what's happened since we started monitoring. So what you're going to see is essentially an activity profile that maps this cityscape-like view of what's going on in this volume. But what's key about this slide is the user for the first time in the industry now has a way to see where my SSD is being applied in relation to the activity. That's the most important aspect of FuzeDrive. So the file pinning, this increased visibility are probably the two strongest tools that go beyond just being not only a high performance tiering engine and the ability to move data, but to also see and monitor that the right decisions are being made by the engine, and then give of course the manual override capability if necessary. Okay, so that's about it. I think as a quick wrap-up summary, FuzeDrive obviously provides a real fast and easy to use solution. We've made this install very easy, as you'll see in later tutorials that we'll be adding to this area here on YouTube and our site. The one other aspect that's very useful to the Enmotus solution is it's both storage and operating system agnostic. You now have one solution which you can use with multiple vendors and multiple operating systems, which keeps your support, integration, and transition costs very low. And of course, one of the primary benefits are that you save tremendous system costs while retaining performance in your environment. You get SSD-like performance, and we've proven this with a number of different applications and benchmarks and tests that for the majority of applications, you do not need to have a whole lot of SSD in your system to get SSD-like performance, but most people do not want to have to manage capacity. So this is the perfect situation, which allows you to have something that's big in capacity, small in SSD portion, but behaves like an SSD. And finally, we're not just another cache. This is a real data migration engine. It's the first in a generation of tools here that we're providing IT managers to be able to integrate and virtualize a great number of devices. And going forward, as we move towards memory class, we expect to have the same level of simplicity applied to what we do here at Enmotus. Thank you for listening, and I look forward to talking to you again soon.